Hi. So now in this video, we are going to see an overview of what are the things that we are going to see inside this course. So we are going to start with what is Web3.js and why do we need it? Because I think whenever we are starting something, we should know why we are actually using it. So we will see that. Then we are going to talk about the types of modules that Web3.js provide us with. Then we are going to see how we can connect to a blockchain using Web3.js, how we can interact with a smart contract using Web3.js, how to compile as well as deploy your smart contract using Web3.js. Okay, so we are going to use only Web3.js in order to compile and deploy our smart contract. We are not going to use any tools like Truffle or Hardhat in order to compile or deploy our smart contract. We are just going to use Web3.js in order to compile and deploy our smart contract. Then we are going to talk about JSON RPC, which actually Web3.js use internally. Then we are going to see what is Truffle and how we can use Web3.js inside Truffle. And then the best part is that we are going to create a project in order to understand how we can use Web3.js library in order to create a decentralized application. So this is just an overview of this course. So please do not think that we are going to cover only 9 topics. This is just an overview. If you want to know more about the topics that we are going to cover in this course, please see the content of this course. So I am highly excited to start this course. So let's start. Hi. So now in this video, we are going to see what is Web3.js and why do we need Web3.js. So Web3.js is a collection of libraries. And why do we need this collection of libraries? We need this collection of libraries in order to interact with the local or remote Ethereum node. So what is this Ethereum node? So this is how Ethereum networks looks like. So you can see that we have various systems and each of these systems are actually connected over the network. And these systems, which are actually part of this Ethereum network, are actually called Ethereum node. Okay, so this is just a terminology in Ethereum blockchain. So whenever a system is a part of this Ethereum network, we call that system as an Ethereum node. And on top of each system, you can see that an Ethereum blockchain is running. So Web3.js is a collection of libraries which actually help us to interact with a local. When I'm saying local, I'm talking about the system that you are working in. So let's say you are a part of the Ethereum network. So your system is a local Ethereum node or a remote Ethereum node. So other than your system, all the Ethereum nodes that you are talking with are actually other Ethereum nodes or remote Ethereum. And how this interaction takes place with a local or remote Ethereum node? This interaction takes place with the help of HTTP, IPC or WebSocket, and for which we are going to see a practical in our upcoming videos. Now you must be wondering, like, okay, I got it that Web3.js is a collection of libraries which help us to connect with an Ethereum node or interact with an Ethereum node. But what is the application of Web3.js library? So let us see the application of Web3.js library, or why do we need Web3.js library as a blockchain developer? Now let's say as a blockchain developer, you want to create a decentralized application. What is a decentralized application? A decentralized application is an integration of your front end with your smart contract. And when you deploy this integration of front end with your smart contract on a decentralized network, you get a decentralized application. Now, this front end can be in any programming language. You can use JavaScript, you can use React.js, AngularJS, whatever programming language suits you. This smart contract can also be in any programming language like Solidity or Viper. So, as a blockchain developer, you need to connect this front end with this smart contract. But the question arises how you are going to connect this front end with this smart contract, because this front end belongs to a real world while this smart contract belongs to a blockchain world. So how you are going to connect this front end, or how you are going to integrate this front end with this smart contract, because these two things are belonging to two different worlds, and that's where Web3.js library come into picture. This Web3.js library act as a bridge between your real world application and your blockchain world application. Means if you want to connect your front end with your smart contract, you need this Web3.js library. So in short, if you want to make a decentralized application, you need this Web3.js library in order to connect your real world application with your blockchain world application. So now let us summarize all the points that we have discussed about Web3.js library. The Web3.js library is actually used to interact with our Ethereum node. And on this Ethereum node, we have our blockchain running. Now, why do we need to interact with our Ethereum node? We need to interact with our Ethereum node so that we can talk to our smart contract. And where this smart contract actually running? This smart contract is actually running on the top of this Ethereum blockchain, right? Because smart contract are something, or I will say smart contract are actually programs that are written on a blockchain. So this smart contract is actually running on the top of this blockchain, and we are able to interact with this smart contract using this Web3.js library. And why do we need to interact with this smart contract? We need to interact with this smart contract so that we can connect our front end with this smart contract so that we can make a decentralized application. So I hope you are able to understand what is the Web3.js library and why do we need it. So I hope you enjoyed this video. Meet you soon in the next video. Hi. So in this video, we are going to talk about Ganache. What is Ganache? Ganache is a local blockchain simulator with the help of which you can run a local blockchain on your system. But why do we need to run a local blockchain on our system? And the reason for this is to test our smart contract. Let's say you developed a smart contract and now you want to test that smart contract. So you can use Ganache in that particular case, because if you deploy your smart contract directly on mainnet before testing it, or to test it on mainnet, in that case you have to pay in real ether. That will be a very costly affair. Like, just to test your smart contract, you have to pay in real ether. So Ganache provides you with a facility that you can test your smart contract absolutely free of cost. And our Ganache looks something like this. So this is our Ganache. Here you can see that Ganache is providing us with some addresses. Like, there are, I think, 10 addresses. And each account has a balance of 100 ethers. All these are fake ethers. Do not confuse it with real ether. All these are fake ethers just to test your smart contract. And when you deploy your smart contract on Ganache, your deployment can be seen on this page, like on this blocks tab. Here you can see all your transactions. Here you can see your contracts, your events, your logs. Everything associated with your smart contract is actually shown in your Ganache. And here you have your gas price, your gas limit, hard fork, network ID, the RPC server, and binding status. So Ganache is something that makes the work of a developer very easy. Like, you do not have to pay anything like in terms of real ether. So just to test your smart contract, you can use Ganache and you are good to go. And we are going to see how to deploy a smart contract on Ganache. So just have some patience. We are going to see a practical demonstration how to deploy a smart contract Ganache, how it looks, how actually all these things works. We are going to see all of these things. So just have some patience. Meet you soon in the next video. So now let us install Ganache to our system. Just click on this download Windows, and we have to wait for some time, and then we will start the installation process. So here we can see that our Ganache is downloaded. Now let's start the installation process. Okay, so now our Ganache is already installed. Now let me click on launch. So we have to wait for some time. So now our Ganache has started, and if you're not seeing anything here, like here you can see that I have some flaky pan Ethereum. So do not confuse, because this is the project I was working on. So you do not need to worry about this. Just click on this quick start Ethereum, and you will see that your Ganache is ready to work with. So it will take some time. Like, it is preparing your local blockchain to your system. So just wait for some time. After some time, your Ganache will be absolutely ready. So here our Ganache is absolutely ready. Here you can see the addresses, the balance associated with these addresses, the private key of these addresses. So everything here, and these are all fake addresses. These are all fake ethers. Okay, these are all fake address and fake ethers. Just for the testing purposes, we have all these addresses and ethers. So here we have our blocks, transactions, contracts, events, logs. And here you can see the the current block, gas price, gas limit, hard fork, and everything is given on this tab. Okay, and we are going to talk more about Ganache in our upcoming videos. Now, in order to use Truffle, we need to install node.js into our system. So just click on node. Like, we are on a website nodejs.org, and just choose, like, I am using Windows, so I'm going to click on this Windows installer. If you are a Mac OS user, click on Mac OS installer, and this is for, I think, for Ubuntu users. So I am using Windows, so I'm clicking on Windows. So I have to wait for some time. So it is a very simple process, and if you already have node.js into your system, you do not need to install it. You can skip to the Truffle installation part. Okay, so this is our dialog box and it is saying to wait. So we have to wait for some time. And now just click on next. I accept the terms of using this. So just click on this, next, next, again, next. It is a simple process as I told you. So what is saying that some npm only used to compile for even installing. If you want to able to install such modules, you can install it if you want to. Just click on the next, then click on install. And now the installation process has begun. But I did not need to install it because I already have node.js into my system and I can show you that. So I am canceling here, but you do not need to cancel it here. Okay. So I can show you that already have node.js into my system. I have to go to my command prompt, simply run node dash v. So if you have already installed node.js or if you are installing node.js, just to check whether node.js has installed into your system or not, just type this into your command prompt, node dash v, and click on it. And here you can see that we have our version v14.717.2. So this shows that node.js is already installed into my system. Okay. Hi, so now in this video, we are going to see how to use Web3.js library in order to connect to our blockchain. So let's start. So first of all, you need to do npm init -y. So this will give you a package.json file here and just make some changes here. Like you should have, let's say, web3, okay, or web only. Let me save it. And now we are going to install one package by the name of web3. Okay, so now let's wait for a while so that it get installed. And you can see that I have created this folder where I am doing all these stuffs. Like you can create a folder in, and then you can access that folder using Visual Studio Code, and then you can perform these actions that I am showing you. I hope you know all these things, but still wonderful. So here you can see that our web3 package has installed. Now let's create one file by the name of web.js. Okay, now inside this web.js we are going to require web3. Okay, we're going to require web3, so we will use require and then web3. Okay, and then now at this point of time we are going to connect to our blockchain web3. Now one important point to note here is this is capital W, right, and this is small w, so don't be confused. Now we will create an instance for our web3. I will show you that web3 dot provider dot http provider. So this will help us to connect to our blockchain. Now let's say I want to connect to our Ganache. So Ganache is a local blockchain, right? So what I will do, I will just copy this down. I will paste it here inside double quotes. Now with the help of this line, now we are connected to our blockchain. Now this is an interesting thing, right? We are connected to our blockchain. Now we can perform all the operations that we want to perform to our blockchain. And let's console.log web3 that we can see this instance that we have created for web3. Now this will help us to access all the functions or the properties that we want, like in order to connect to our blockchain. So now how we can run this file? Now in order to run this file, you will write node and then web.js. So we are using actually node.js in order to run this file. Okay, actually we have made some mistake. Okay, it should be providers, not provider. Sorry for that. Let me save it. Let's try to reconnect and be sure that your Ganache is running in this case, right? Otherwise it will give you an error. So be sure about that. So now you can see that we have this instance of web3. You can see that we have lot of methods, lot of key value pairs, right? Let me scroll up a little bit. Okay, so here you can see that. So we have all these things and we are going to use some of them also, like in order to connect to our blockchain. You can see that we have this contract, we have this personal, and you will understand what these things are once we will start. But you can see that we have lots and lots of functions, right? Okay, wonderful. Now let me close this down. Now let's do one thing. Let's talk to our blockchain. Now let's talk to our blockchain, this Ganache blockchain, and let's communicate and ask him like what is the address of this account. Okay, now what you can do here is you can write async. Okay, because we are going to deal with a lot of promises, so we will use async get balance. So this is a function that we are actually using. And now we will use const balance, and we will use await since we are dealing with promises, right? So web3 dot eth. And what is this eth? Just don't worry about it. We are going to talk about it in more detail in our upcoming videos. For now, just concentrate on how we can talk to our blockchain. Dot get balance. And then inside this, we will paste the address of this account. Just copy this down and then paste it in and then save it. And now inside this, we are going to console.log this balance. Now we have to call this get balance function, right? So let's call this and let's see get balance. Let's save it, open our terminal. Let me clear the console. Now let's do node web.js again. Wonderful. Actually, this is console.log, right? That's why we are seeing this. Let me comment it out. But here you can see that we have this amount of ethers in our this account. Okay. Now you must be thinking like in this, if we will go to our Ganache, it is in like 100 ethers, right? But why we are seeing such a large value? Actually, this thing is actually in Wei. Okay, 100 ether has been converted in Wei because web3.js mostly deals in Wei only. Okay, and we will talk about this in more detail in our upcoming videos. But for now, you can see that we are fetching the balance of this account. So we are actually talking to our blockchain, and that's a wonderful news, right? So I hope you enjoyed this video. Meet you soon in the next video. Hi. So in this video, we are going to talk about the various modules that web3.js library provide us with, which makes the life of a developer very easy. So let's see. So the Web3.js library is a collection of modules that contain functionality for the Ethereum ecosystem. If you do not understand this line, do not worry. We are going to understand it in just a second. So if we talk about Web3.js library, Web3.js library provides us with various modules such as Web3 means Web3.eth, which we have seen in our previous video, right? Where we use Web3.eth.getBalance. Then we have Web3.utils, which contains useful helper function for Dapp developers. So this module is also helpful whenever you are creating a decentralized application, and which we are also going to see in our upcoming videos, like how to use Web3.utils. And then we have two more modules, that is web3.ssh and then web3.bzz, but we are not going to use them much. So we are not going to talk about them like much in this course. Mostly our focus will be on this web3.eth and web3.utils. Definitely, if you want to know more about them, that is about this web3.ssh and about this web3.bzz, definitely you can look to the web3 documentation. But you will not use them like much whenever you are creating a decentralized application or whenever you are talking with the blockchain and smart contract. For that, we only need these two modules, that is web3.eth and web3.utils. So in the previous video, we have seen how to get the balance, right? And for that, we use this module web3.eth. Now let us do one thing. Let me show you what are the functionalities that web3.eth actually provide us with the help of which we can communicate with our blockchain and smart contract. So what I will do, I will console.log this web3.eth. Okay, let me run this web.js. So this web3.eth provides us with various functionalities which actually help us to talk to our smart contract and to our blockchain. So here you can see that. So these are the various functions: request accounts and get pending transaction. Let me show you this get balance also here, get balance, which we have used, right? Let me show you that also. So if you will like do one more click, yeah. So here you can see that we have this get balance function, which we actually use also at this place, right? The same way we have for various functions for our web3.utils. Let me show you that also. So again, I will web.js. So here are the things that web3.utils actually provide us with. So you can see that, and all these functions are very useful for a Dapp developer. Like say, for example, you need to check like you want to convert from one unit to another unit. Let's say you fetch the balance. Okay, like in this case, we have fetched the balance, right? In this case, we have fetched the balance of this account. So I want to convert this balance into Wei, or I want to convert this balance into Ether. So all these things can be possible with the help of this web3.utils modules, and which we are going to see in our next video only, like how to do this unit conversion and everything. And you can see that we have this functionality of to Wei and from Wei, which you will understand when we will do it practically. So these are the two modules, that is web3.eth and web3.utils, which we are going to focus in this course. Okay, which will help us to communicate to our blockchain, that is web3.eth. And in order to become a Dapp developer, there is this web3.utils, which makes the life of a Dapp developer easy. Okay, so this is all about in this video. Meet you soon in the next video. Bye bye. Hi. So in this video, we are going to see how to do unit conversion using Web3.utils. So in our previous video, we have seen how to fetch a balance of a particular account, right? Like, let me show you my Ganache. So now you can see that my Ganache have some different addresses. It might be different in your Ganache. And the reason for this is that Ganache actually changes these addresses. Okay, whenever you are reopening your Ganache, you will find some different addresses whenever you are reopening your Ganache. And why this is, I do not know, but yeah, this is the case whenever you are doing this quick start. Okay, so that's why if I will go for this account, you will see that you will not find this account in my Ganache. Okay, so what I will do, I will copy one of these accounts which are actually provided by Ganache currently. I will copy this and I will paste it here, and let me do one thing. Let me again console.log the balance. Okay, console.log balance. Let me run this node web.js. Let's see the balance of this account. So currently you can see that this is the balance of this particular account, right? But this balance, if you will see, this balance is actually in way, right? And the balance that is actually being shown in our Ganache is actually is in ether. So what we can do in order to convert this huge amount of balance, or I will say this way amount, to a ether account. So for that, we are going to use a library or a module called web3.utils, right? Which we discussed in our previous video. So now let us use this web3.utils. Okay. So first of all, I will declare one variable balance to ether. Okay. So this will have the balance of this account in ethers. Then we are going to use await because we are dealing with promises, web3.utils. And in this, we are going to use from way. Okay, remember this function from way. And in this, we will provide the balance, means this balance which we want to convert into ether. So I will do balance and then comma, and here you will write ether. Okay, so this will actually give you balance in ether. And to check that, you can print this balance to ether, save this, run this again. Hooray, right? Here you can see that. So now this VE amount get converted into this 100 ether. In the same way, you can convert this balance ether, like the balance which is actually given in ether, into way. And how you can do that, and you must be thinking like, why I'm telling you all these things. I'm telling you all these things because this will be very helpful whenever you are creating a decentralized application. Because whenever you are creating a decentralized application and you want to show the data of a particular user, let's say you want to show the balance of a particular user on the front end, right? So in that case, you need to convert that balance, this huge amount of, like, you can see that this is so much big, right? So it is very hard to read, so you need to convert this to ether, right? So all these things will be helpful in that scenario. And with utils, which we have discussed before, also is actually used for Dapp, like whenever you are creating a Dapp, right? Decentralized application. So now let me do one thing. Let me convert the balance to ether again to way. So for this, I will again use await web3 dot okay. For that, web3.utils, and in this I'm going to write two-way. Okay, not from way but two-way. And in this I will write balance to ether, the balance that I want to convert into way. In this you have to mention ether only, and do not confuse like why in this we have to write ether, like in this also we have ether, right? But actually the thing is, we are converting this ether amount to way. Okay, in this the thing was, we are converting this from this balance way amount to ether. Okay, so it is something like we are in this, we are going from this to this, and in this we are actually going from this to this. Okay, so something like that. So do not be confused, just remember this syntax. Okay, so I will then, let me print this way amount only. And now I will again do this console node web.js. Let me see. Wonderful. So now you can see that this balance to ether, which actually contain the balance of this account in ether, has been converted into way using this utils.toWay function. Hi. So now in this video, we are going to see how we can transfer ether from one account to another account using web3.eth module. Okay, so let's start. So first of all, we will create one variable by the name of txn or any name that you want. Then we are going to use our await, since we are going to deal with promises, web3.eth.send transaction. Now this is a function that will help us to send transaction from one account to another account. Now inside this function we will have an object in which we will mention the address one, that is the address who is actually going to perform this transaction. So let me go to our Ganache. Let me take this account. Okay, let me copy this. We will use double quotes. Inside this we will paste this address, and then we will have another account 2 to whom we want to send some ether. Okay, so let me again go to Ganache. Let me copy this account. Okay, and again double quotes, and we will paste this here. Okay, and now we will tell the amount of ether that we want to transfer from this from account, that is this account, to this account. Okay, so we will have our value. Now inside value we are going to tell like how much amount of ether we want to transfer from this account, that is this account 0 cross 7b55 to this account. Okay, and the value will be in terms of way only. Okay, so you do not need to pass a value in terms of ether, you need to pass this value in terms of way, because most of the transaction that we do using web3.js library are in terms of way. Okay, so we are going to use our web3.utils library, and we will convert our way, which we have also seen, right, the syntax earlier also, one way or one ether actually into way. Okay, so what we are trying to do is we are actually transferring one ether from account to account. Okay, but in terms of way. Okay, wonderful. Now let me save it. Now let us run this. Okay, now let me show you the initial balance of this account. Initial balance of this account is 100 ether, and initial balance of this account is also 100 ether, right? And now we are transferring one ether from this account to this account. So let me run this node web.js, and let's see. Okay, we can do one thing more. Definitely the transfer has been taking place, if you will see. So now you can see the balance of this account is 99 ether and the balance of this account is 101 ether, because one ether has been transferred from this account to this account. Okay, but let me do one thing. Let me console log this also, so that we can see console log transaction successful. Okay, so this will make it more easy, or not easy actually, more clearer when we are doing this node web.js. So now let me run this. Wonderful. So our transaction is successful. Let me go to Ganache, and now you can see that now this account has 98 ether, because 2 ether, because 1 ether was transferred initially, and then again 1 ether has been transferred from this account to this account. So now this account is holding 102 ether, and this account is holding minus 2 ether, that is 92 ethers. So this is how we transfer ether from one account to another account using web3.eth module. So now let us see how we can interact with a smart contract using web3.js library. So this is our remix ID, in which I have written a very simple smart contract by the name of demo, in which I am declaring a variable 10, and then I'm getting the value of this 10 using this variable x using this get function, and then we have this set function in order to set the value of this x variable. Okay, so now let us do one thing. Let us go to our deploy section. Inside this, just select injected, no, not injected web3, actually web3 provider as your environment. And in this, if you will see, what we are actually trying to do here is we are actually trying to connect our remix ID with our Ganache. Okay, so in order to do that, we will write 7545. Okay, because for our Ganache UI, if you will see, it is having a RPC server of HTTP 127.0.0.0.1.7545. Okay, so let me click on OK. Now once you will click on OK, you will see your Ganache account appearing here. Okay, let me show you that. So this is our Ganache having these accounts, right? 0 cross and 9118. Let me show you this. So here also you can see that. So we have all these accounts available to our remix ID. So now let us deploy this smart contract. So once we will deploy this smart contract, it will get deployed to our Ganache blockchain, because now we have selected our Ganache blockchain, okay, as an environment for deployment. So now let me click on deploy. You will understand why I'm doing all these things, because we are going to need the ABI of this code in order to interact with this using Web3.js library. So this is our deployed smart contract, right? You can see that we have this set function, we have this get function, and here is the address of our smart contract. And if I will show you in our compile section, this is the API of our smart contract. Okay, so we are on our web.js file. Okay, now in this we are going to interact with our smart contract that we have just deployed to our remix id, not to our remix id actually, by using remix id on our Ganache blockchain. Okay, so first of all we need a package contract, and this is actually provided by our web3.js library only, so we do not need to install anything new. Simply we will do require web3 eth contract. Okay, now we will create one async function. Let me name it as instance of our contract. So let me name it as instance contract. This will help us to provide the instance of our smart contract which we are going to use. Let me call this function also so that I don't forget. Now inside this, I'm going to create the instance of our smart contract that we have just deployed to our Ganache blockchain. So for that, I will write const contract. Okay, let me name it as contract. And one more thing that I have to do, let me first of all create the instance new contract. Okay, now inside this, we have to provide two things. First thing is the ABI of our smart contract, and another thing is the contract address. Okay, so these are the two things that is required in order to have the instance of our smart contract. And do one more thing, just set the provider, means the blockchain that we are going to interact with. Set provider. Inside this we will mention the blockchain URL. So since we are going to talk with our Ganache blockchain, right, so I will mention that here. Okay, now let us fetch the ABI of our smart contract and the contract address. Now we can declare two variables also by the name of ABI. Okay, so this will make our work a little bit of easy, I will say. And then one more variable by the name of contract address. Okay, now let's go back to our remix id, and in this let me copy the ABI and I will paste the ABI of our smart contract here. Okay, so it is something big, right? It's something like, you can see that it is a big value. And then let us fetch the contract address, which we can see in our deployed section. So this is our contract address. Let me copy this down. Let me go back. Let me paste it inside a double quote. So this is our contract address. Okay, I'm seeing one issue. What is the issue that? Okay, I think we should not name this. Okay, I made a mistake. Sorry, guys. I actually did a space, right? We should not have a space between variable when we are declaring a variable. So now we have this contract address. So now what we will do, we will simply take this ABI of our smart contract. We will paste it here. Okay, and then we will take this contract address and we will paste it here. Okay, so now we have the instance of our smart contract in our contract variable, and we can see that also. Console.log. Inside this, let us print this contract instance. Okay, let me save this. Let's try to run this. Node web.js. Let's hope everything works fine. Wonderful. So now you can see that we have this instance of our smart contract. And how can I say that? Let me show you. So you can see this, that we have this, if I will search for our set function. Okay, let us take Control plus F. I will search for our set function. You will see that we have this set function, as well as we have the a get function also. Let me show you. So now you can see that we have this get function, as well as we have this set function that we have declared in our smart contract, right? Wonderful. So now let us do one more thing. Now let us call our set function. Let me go to our methods. Okay, so here it is. So this is our methods, right? Inside this method, you can see that we have this set function and we have this get function. Now let us call this set function. Okay, or let us call first of all this get function. Okay, so how we can do that? Let's see that. So we will go there. We will write contract in contract, we have to go to this methods, right? So methods dot, and we will call our get function dot call. And inside this, if you want to mention, you can mention from which from which account you want to call this get function. Okay, so let me go to our Ganache. Let me select this account, copy this. Okay, let me paste this here. So from this account, I want to call this get function that is actually mentioned in our this smart contract. Okay, okay, okay. Now, since we are dealing with promises, I can directly do then and then console dot log, right? I hope you know this. This is the syntax from our JavaScript only. So you can see this. So we have, let me zoom out a little bit. So now you can see that we have this contract dot methods. So we are calling this methods. Inside this, we are calling this get function, and we are calling this from this account, and then we are console log this whatever value this get function will return us with. Let me do one thing. Let me comment this out. We do not require now. And now let us call this node web.js again. Web.js. If everything works, we will have 10 as a value, and here we can see that. Wonderful. So now you can see that how we are going, like how we are able to interact with our smart contract using web3.js library, right? If you will see, if you will go back to your smart contract, let me show you. So now you can see that we have this variable x as a value 10 only, right? So when we call this get function, okay, this return us with this 10 value. Definitely this value, like this smart contract is already deployed, right, in this, like which we can found here, right? So this is our deployed smart contract which we are interacting with. Okay, and when we had deployed a smart contract, in that x was equal to 10, that's why it is actually giving us the value of equal to 10 when we are calling this get function using this web3.js library. Okay, so I hope you enjoyed this video. So I will share this code with you so that you can see that also. Hi. So in the previous video, we have seen how to interact with our smart contract, and we have called this get function in order to get the value of this x variable, right? Now in this video, we are going to see how we can change the value of this x variable using this set function. Now both of these two functions are actually different function. Different as in this get function is actually not changing the state of our blockchain, right? This get function is something that is just returning us the value of this x variable. But this set function is actually changing the state of our blockchain, right? Because x is actually a state variable. And when we are calling this set function, we are actually changing this state variable. So we are changing the state of our blockchain. So now let's see how we can call this set function using our web3.js library. Now, one thing, let me tell you that you might see a different contract address and a different account address as compared to our previous video. And the reason for this is that by mistake, I actually closed my Ganache, and that's why I lost all my data, means the contract address as well as the account address. So that's why I have redeployed our smart contract, and this is the new smart contract address, and you do not need to worry, right? The concept remains the same, only the contract address and the account address is changed. I can show you that also. Let me call this node web.js. You can see that we have this 10 value, and in our remix id you can see that we have this 10 as a value. Okay, so only the contract address and the account address is changed, everything else is the same. Now how we can call this set function? Now in order to call this set function, we need to have a different function, and let me copy this down, and that function is send function. Okay, so you cannot change the state of your smart contract using the call function. You can change the state, or me when I'm saying state, you can change the variable or state variable of your smart contract by using send function only. Means whenever you are changing the state of your smart contract in any way, then you are going to use the send function. But whenever you are not changing the state of your smart contract, in that case you are going to use this call function. And let me remove this console.log, because with the help of this set function, because we are going to set the value, we are not actually getting the value, right? So we do not need that dot then. And let me remove this. Now I think everything is correct, right? So we are calling this set function using this send function, okay, of our web3.js library. and let me set the value of this x variable to be, for example, 50. Okay, because our set function is actually taking this argument, right? So we are passing 50 as an argument. Let me save it. Let me call this node web.js again. So you can see that still it is showing 10, right? So it will take some time when to make the changes in the blockchain. So it will take some time. So let me again call this node web.js, and now you can see that now we have 50 as the new state value of our x variable. And how we can say that? Because this is actually calling our get function, and this get function is returning us this 50 as a value. If I will change this to, let's say, 500, or let's say 500, and again I will call this node web.js. So again it is taking some time. Let me again do this. Okay, so now you can see that we have this 500 as the new value of our x variable, and the same thing you can see in our remix id also. Let me call this get function. So you can see that we have 500 because our remix id is actually communicating with our Ganache blockchain, right? In our Ganache blockchain, if you will see, we have our contract address as 0x4EA. So let me show you the contract address in our remix id also. It is 0x4EA. So whenever we are making some changes in our smart contract, means the smart contract that we have deployed, means this is smart contract, those changes can be seen to our remix id because remix id is actually using Ganache blockchain only, right? So this is how you can make changes to your smart contract using this send function. So remember, whenever you are going to change the state, you are going to use this send function. When you are not going to alter the state, then you are going to use this call function. Okay. Hi. So now in this video, we are going to see how we can compile our smart contract using Web3.js library. So let me show you the contract that we are going to compile. So this is our contract that I have created in our master Web3 folder. Okay, master Web3 folder, I have created this demo.sol smart contract, and we are going to compile this smart contract using our web3.js library, and then we are going to generate the bytecode as well as the ABI of the smart contract using this web3.js library. So till now you might have compiled your smart contract using remix id or using Codam compiler, but now we are going to see how we can compile our smart contract using web3.js alone. Okay, so we are going to do everything from scratch. So let me go to our web.js file. Now in this, in order to compile our smart contract, we are going to need one thing, that is our compiler. This is our Solcy compiler, which is going to compile our smart contract. Okay, so this is required. So we need to install this Solcy compiler. Now how we can let us first of all do one thing. Let us install this. Simply go npm install and then Solcy. Okay, so this will, okay, where it is. Okay, so the installation has started. So now let us wait for the installation to complete. Okay, so now you can see that my Solcy compiler has been installed to my this node modules. So now I can go back. Okay, let me close this. So this is our Solcy compiler. Okay, now we require one more thing, one more package, that is fs package. This will help us to read our smart contract. So this is a part of our JavaScript file, means JavaScript language, JavaScript programming language. Then we will require our web3, as always, require web3, and now we need to have our web3 inside our web3 variable. Okay, so I'm not using those let and const. It will be done by default, like by our VS Code only. So new web3 dot providers, okay, dot http provider, and now we will provide the Ganache URL. So let me put this down. Let me paste it here. Okay, let's read the content of our file. Okay, our demo.sol file. So file content is equal to fs.read. All these things that I'm using related to fs is actually part of JavaScript programming language. Okay, so it has nothing to do with web.js or Solidity. So demo.sol. So if you will see, this is our contract name, right? Let me show you. So demo.sol, and now we will convert this file into a form of string. Okay. Now we require one thing, and let me copy paste that. So this is our input structure for our solc compiler. Okay. So we have provided which language we are going to use, the source, that is demo.sol. If you are using some other smart contract, means if you are using some smart contract such as abc.sol, then you have to mention that only, and all these things will remain the same. Okay, just copy paste this line. I will provide you the file. Okay, after this video only, you can just copy paste this line in order to have this input structure. Now we are going to generate our output, and we are going to generate it using the input structure that we have just copy pasted. Okay, but the input structure that we have just pasted is not more than enough. We need to convert it into various format. So this is our input. First of all, we need to convert it to json.stringify, otherwise it will not be accepted by our solc compiler. Now we will provide this input to our solc compiler. Okay, so solc.compile. Okay, and now we will parse this using json dot parse. Okay, because this is necessary in order to create the ABI as well as the bytecode of our smart contract. Now we will generate the ABI. ABI is equal to, and do not worry, you do not need to remember all these things. I'm just showing you how you can do all these things from scratch. If you require these things, just copy paste these lines, these files to your project and just use it. Okay, like this only. So you do not need to remember all these lines. Output dot, now we are going to require the, in this we will provide the smart contract name, and in this we will provide the name of our smart contract that we have given, right? So demo, let me show you. So demo.sol, demo is our smart contract, right? And then we will create the ABI using this. If you want, you can, I will show you this also. Let me show you this so that you can better understand it. Let me do one thing. Instead of generating ABI, let me first of all console.log this output. Okay, so that I can show you. And anything else if you want to see, let me show you this file content also. Okay, so file content, whatever. Now let us run our web.js file. Let's hope everything works. Web.js. Okay, so I have made some mistake, I think. Okay, assignment to constant variable. Okay, I do not know how this actually came. Let me try one more time. Okay, now let's see. We have some error, I believe. So it is saying at, okay, actually we have made a mistake here. It should be read file sync, okay, not read file, and everything else is correct. Let me now try to do it once more. Actually, it is a complicated structure, don't you think? Yeah, it's a very complicated structure. So there are possibility that you might make some mistake. Okay, so now I think it worked, and now you can see this is our file content, right? This is our file content. So we have actually read our smart contract, right, at this line. So reading our smart contract. Okay, so we have read our smart contract, and now you can see that we have our smart contract in this file content variable. And now in this you can see that we have this contracts. This is our output. This is our output, okay, that we have just console.log, and now we are going to use it in order to generate our ABI. So now let me generate this ABI. Now let us use this again in order to generate our bytecode. So I will do byte code. In this I will mention demo.sol demo. In this, just mention evm dot bytecode dot object, and that's it. And let's console.log this bytecode. Okay, and let's console.log this ABI. So this is our ABI, right? Okay. Let me again comment these things because we do not require them, right? And this thing also. Now let us try to run this again for web.js. Hope everything will work. Okay, wonderful. So now you can see that we have generated our bytecode as well as our ABI of our smart contract of this demo.sol smart contract. And that is just wonderful, don't you think? And in this, you can see that we have this ABI, like how we can say that this is the ABI for this smart contract, because we can clearly see that we have this set function, we have this okay get function, which we have actually mentioned in our smart contract also. So in the next video, we are going to see how we can deploy this smart contract using web3.js library. So I hope you enjoyed this video. Meet you soon in the next video. Hi. So in the previous video, we have seen how we can compile our smart contract using web3.js library and how to generate its ABI as well as bytecode using web3.js library, right? Now in this video, we are going to see how we can deploy our smart contract over Ganache blockchain using web3.js library, okay? So now let's start. Now this is going to be a little bit complicated structure because we are going to use a lot of promises. So there will be a lot of dot then and all those things. So just be patient. Do not worry if you do not understand anything. Just have some patience and you will understand at the end of this video. Okay. And I will provide you all the files and everything after this video only. So you can copy paste from there only. Okay. So now we will, first of all, we are going to require the instance of our smart contract. And for that, we are going to have a variable contract. In this, we are going to use web3.eth in order to have the instance of our smart contract. So contract and then ABI. Okay. So this is a different way how you can get the interface or instance of your smart contract. Then we are going to require an account in order to deploy this smart contract. So let me have a default account. Definitely you can name it as anything and name it as default account. And now we are going to use web3.eth get accounts. So this will actually provide us with all the account that is actually present in our Ganache. Okay. And then we are going to have the accounts inside our accounts variable. Okay. Now if you want, I can, so if you will console.log this accounts, you will see all the accounts that is present in our Ganache. This is because of this get accounts function. Okay. So let me show you that also, accounts. Okay. And then we will have as a default account, this account 0 means, let me show you. So our accounts array will consist of all these addresses. Okay. And the default account will be this address. So this is at index 0, right? This is index 0, index 1, index 2. So I'm making this account as our default address, who is actually going to deploy this smart contract. Now we are going to deploy our smart contract. So contract. So we have the instance of our smart contract in our contract, then deploy. Okay. Now in this, we will have our data variable and the bytecode. So the bytecode that we have generated, right, at this point of time. And now let me make it more cleaner by having this here. And again, we will have our send function, means from which account we want to deploy this smart contract. So we will have our default account and let's have the gas limit as 47,000. Okay. You can increase or decrease the gas limit or make it, let's say, make it this. Okay. So that it does not fail when we are deploying our smart contract. Then on receipt. So this will help us in getting the address of our smart contract, and we are going to console. Okay, console.log this contract address. Okay, so this will console.log our contract address. Let me save it. Now let us run this. Let's see whether the deployment process is taking place or not. Okay, so now you can see that we have our contract address, and this contract has actually been deployed to our Ganache blockchain. Means our deployment process is actually working very like absolutely fine, and we can see that in our Ganache also. So in our Ganache, let us go to our blocks. In blocks, just click on this, and in this you can see that you have this contract address which is just deployed to our Ganache blockchain, and this is done using this thing that we have done, right, using web3.js library. So congratulations, you have successfully deployed as well as compiled your smart contract using web3.js library. I hope you enjoyed this video. Meet you soon in the next video. So if we talk about web3.js, what is web3.js? So we have seen this definition, right? That web3.js is a collection of libraries that allow us to interact with a local or remote Ethereum node using HTTP, IPC or WebSocket, right? And this web3.js provide us with JavaScript APIs in order to communicate with blockchain. And we have seen this also, right? We have different type of modules like web3.eth, web3.utils. All these things are nothing but these are all JavaScript, right? And because web3.js is a JavaScript library, so web3.js is actually providing us with this JavaScript APIs in order to communicate with blockchain. And internally, this JavaScript API is actually using JSON RPC in order to communicate with blockchain. Now, the question is, what is this JSON RPC? So now let's talk about it. So what is this JSON RPC? JSON RPC is a stateless, lightweight remote procedure call protocol. If you do not know anything about all these things, what is this remote procedure call and all those things are, do not worry, you will understand. We are going to take an example to understand it in a better way. It uses JSON as a data format. In Google, just search for Ethereum JSON RPC API. Okay, and just visit this link, that is https eth.wiki. Okay, JSON RPC. Let me open it. Okay, so in this you can see that JSON RPC is a stateless, lightweight remote procedure call protocol. Primarily, this is specification defines several data structures and the rules around their processing. It is transparent, agnostic in that concept can be used within the same process over sockets, over HTTP, or in various message passing environments. I know this definition is a little bit complicated, but you will understand it when we are going to see an example. So just search for accounts. Okay, just search for accounts. Now this is eth accounts. So if you remember from our previous video, we have used a command, right, web3.eth.get accounts, which actually help us to get all the accounts that were present in our Ganache blockchain, right? So that command actually was using this JSON RPC format internally, and we can prove this also. Okay, so let me copy this down. Now let me open Postman. This Postman software is actually used in order to test your APIs. So we are going to test it using Postman, like how web3.js library is actually using JSON RPC format internally. Okay, so the installation process of Postman is very simple. You have to just simply click on, like, type on Google Postman download, and you will be able to download this Postman. Once you will download this Postman, you will see an interface something like this. And now just click on, okay, so we have a lot of tabs already open, right? Let me close all of them. Okay, now let me open one of the tabs. In this, just select post, and inside this request URL, just have your Ganache URL. This is our blockchain, right? So we will have this URL, and then go to this body tab. Inside body tab, just go to raw. In raw, select JSON. Okay, because this is in JSON format. Let me go back to this again. Let me copy this. Okay, I will copy this command only, and I will paste it here. Okay, so this command will help us to fetch all the accounts that are present in our Ganache blockchain. Let me send it, and here you can see that. So we have all the accounts that are present in our Ganache blockchain using this JSON RPC format. So this proves, right, that whenever we are using web3.eth.get accounts, so internally is actually using something like this type of format, right? This JSON RPC format. You can match this also. It is 0 cross 719, right? In this Ganache blockchain, we also have this 0 cross 719. In the same way, let me test another command. let me test for get balance. We have seen this also, right? Get balance. So for this, I think we have this type of command. Okay, this are JSON RPC format. So let me copy this. Okay, let me go back to Postman. In Postman, again go to this raw, paste this, and now just change this params, right? Because this is having their own demo account. We will have our own account. So let me copy this account and let me have it here. Okay, let me again do this. Wonderful. So now let's click on send. So this command will help us to fetch the balance of our this account, and you can see this also that we have the balance of our account. This is in hexadecimal number. So let us convert this number to decimal. So let me go for hexa to decimal converter. Let me paste it here. Let me convert it. So now you can see that we have this huge amount of number. Actually, this is in WEI. Now let us convert this number into ether. Okay. So we will go for WEI to ether converter. Let me paste this amount in WEI, and now you can see that we have this ether, right? 99.994. Let me open our Ganache. This account balance is approximately equal to 99.99, right? So by this, we can clearly see that whenever we are using Web3.js library, internally, it is actually using this JSON RPC format in order to communicate with blockchain. So I hope you enjoyed this video. Meet you soon in the next video. Hi. So now in this video, we are going to see how we can create a decentralized application using Web3.js library. Okay. So I'm in this folder, Truffle Web3. You can create a folder inside your Visual Studio Code and then just open your terminal. And to open your terminal, you can use this menu. So just click on new terminal and you will have a terminal open, or you can use this Control plus Shift plus this back tick. Okay. Now in the terminal, just type Truffle unbox React. So this will actually provide us with the environment in which we can create a decentralized application in a very easy way. Okay. So let's wait for some time till it get downloaded. Okay, so the installation is complete, and now in our Truffle Web3 folder, you can see that we have various folders, and we have this Truffle configuration file. We have this client folder in which we are going to create our decentralized application, in which we are going to write our React.js code. We will talk about this. This is our folder in which we are going to create our smart contract. So we will be using this smart contract only in order to create our decentralized application. Okay, so in this, just change some of these things. Let me make it 0.5.0. okay, and it is good, but let us make this 0.9.0. okay, so that you can use it in other versions also. Okay, if there is an upgrade to 0.8.10. okay, it is showing us an error. Okay, the error is gone. That's good. You can remove this file. We do not actually require this file, so you can remove this. Let me delete this. Okay, and we are going to use this smart contract in order to create our decentralized application. And in this, let us do one more thing. In our migrations, let us delete this also, because this was actually associated to our migrations.sol file, which we have deleted, right? So let me delete this. Let me rename it to, okay, sorry for that, one deploy contract.js. okay, it's good. And we do not require a test folder because we are not going to test our decentralized application. So if you want to remove, you can remove this also. Okay, now let's check out our client folder in which we are going to create our decentralized application. And before that, let me show you this Truffle configuration file also. Like, what does it actually say? So you can see that this Truffle configuration file is a slightly different from the Truffle configuration file that we have seen earlier also, because right, when we are talking about Truffle, in that the Truffle configuration file was pretty long, right? It was pretty big. But in this case, you can see that we have just some of these things. One of the things is this contracts build directory, the JSON file that will be generated, right, which actually contains the ABI of our code. ABI of our smart code will be inside this contracts folder that will be created inside our source folder. So inside our client, you will see in our source folder, there will, when we are going to compile our smart contract, you will see that a contracts folder will be created, and inside that contracts folder, you will see the JSON file associated with this simple storage.sol smart contract. Okay. And then we have this networks tab, which is actually telling us that at which network we are going to deploy. Since we are going to use our Ganache, right? This Ganache 7545. So I will make it 7545. Okay. And for your compiler version, you can simply copy paste this line. Okay. Simply copy paste this line. Okay. I think I have written it now. One less brackets, right? Okay, now it is good. So I have just pasted this compiler version, which will actually tell us like which compiler version we are going to use. So we are going to use 0.8.9 compiler. Okay, so this is it for this shuffle configuration file. Now let me go to our app.js. Now inside our app.js, you can see that we have a code written in React.js as well as Web3.js library. Okay, but we are going to create this thing from scratch. We are not going to use this template because this template is a old one. You will see that it is using React.js, but this React.js code is old, right? It is not using the ES6 version. So we are going to create this whole thing from scratch. Okay, but let me run it for you so that you can see that. Okay, and before running it, we need to compile our smart contract so that we can generate the ABI of our code. Okay, so you will understand all these things when we are going to create this file app.js from scratch. Okay, for now, just for demonstration purpose, let me compile this smart contract. So I will do, okay, so our contracts folder is inside our truffle web3, right? So I will do truffle compile, and let me show you that the JSON file will be generated inside our client folder in this source folder, right? So when I will hit compile, you will see that a contracts folder will be created inside this source folder. Wonderful. So here you can see that we have this contracts folder created inside the source folder, and this contracts folder consists of this simple storage.json, this ABI as well as the bytecode related to our smart contract. Okay, this will help, like this code will be necessary when we are going to communicate with our smart contract, because in order to communicate with our smart contract, we need the ABI of our smart contract. And here you can see that in our app.js file, we are using this simple storage.json file in order to generate the ABI of our smart contract. Okay. Okay. So now let us deploy our smart contract. Okay. So that we can communicate it over the Ganache blockchain. So I will write truffle migrate dash dash reset. So this will migrate our smart contract, this simple storage.sol smart contract over our Ganache blockchain. Okay. Okay, so now the deployment is done. Now let's cd to the client, and now let's run our React application. So I will do npm start inside our client folder. Let me press enter. Now this will run our React application, our decentralized application. Okay, I think something is running over port 3000. So let me press yes. For you, it might be different. Okay, so now the React application is running at port 3001. Okay, for you it might be port 3000. Okay, I think in my system 3000 was not available, that's why it is running it on port 3001. So it will take some time, but when your React application will open in your browser, you will see that you will have an error. And the error will be because that this React application will actually ask for this MetaMask wallet authentication. Okay, and since in your MetaMask wallet might be connected to a different network, in that case it will give you an error. Like in my case, you can see that my MetaMask wallet is actually connected to my Ganache blockchain, to my Ganache network, which I will tell you how you can connect it to. But in your case, it might give you an error. Like you can see that in my case, it is running very fine because I have connected my MetaMask wallet to my Ganache blockchain. Now, how you can do that, let me show you. So this is how our decentralized application actually looks like. Okay. So let me show you how you can have your Ganache running inside your MetaMask wallet. Now, in order to do that, first of all, let me Okay, I think it is asking for like this decentralized application is asking for the transaction to be successful, to run this transaction in order to be successful. Let me reject it for now. Now in your MetaMask wallet, just go to this symbol. Inside it, just click on settings. In settings, just click on networks. In networks, just click on this add network. So when you will click on this add network, you will have this type of interface. Just wait for a while. Okay, inside this network interface, just mention Ganache. Okay, and then the RPC URL. The RPC URL is this URL that you are seeing. Okay, like this. Like in my case, you can see that my Ganache is already running right in this particular case, so I cannot use it. But in your case, it will not be an issue since you are not connected to Ganache. Then you have to mention the chain ID. Now I do not remember the chain ID of Ganache, so let me see that. Just a minute. Go to settings, networks. Okay, for Ganache, the chain ID is 1337. Just enter this chain ID, and in the currency symbol, you can mention anything, whatever you want. It is just optional, but sometimes it does not allow you to save. That's why I have written this ET. You can write anything, whatever you want. Okay. And once you have done that, just click on the add network button. Okay. So just let me copy this also for you so that I can show you once again. So simply I will go to settings, I will go to networks, I will click on add network. In add network, you can name it as Ganache. For RPC URL, you have to mention this link, and in chain ID, you have to mention 1337. And in the RPC URL, just paste this as your RPC URL. And in currency symbol is optional, so you do not need to mention. But if you want, if it is not giving you an option for save, in that case you can write something. Okay, like I have done, and just click on save. You will have a Ganache network connected to your MetaMask wallet. Now once this is done, your work is still not ended. You have to go to your MetaMask wallet. Let me show you. You have to go to your MetaMask wallet. You must be seeing this Ganache connected to your MetaMask wallet. Now you need to import an account in order to run this, like to have some ether in your MetaMask wallet. And for that, you have to go to your Ganache, go for any of these accounts and just click on this show keys. In show keys, select the private key of any of the accounts that you want to import to your MetaMask. Click on done and then go to your MetaMask wallet. It's a lengthy process, but it's just for one time. And then click on this icon, go for import account. In import account, just paste the private key that you have just copied, click on import. Now once you will do this, you will see some amount of ether or the ether that is present in your Ganache available to your MetaMask wallet also. So now our work is done. Now we just need to connect this account to our decentralized application. So I will click on not connected, I will click on connect, and now my MetaMask wallet is connected to this decentralized application. Let me refresh it. Okay, so it is asking for our transaction. Let me confirm this. So now once I will confirm, let's see what will happen. Okay, so our transaction is confirmed, and now you can see that our value 5 is actually stored at this decentralized application, I will say. Okay, so this is how our decentralized application is looking. Good to go. Your truffle box is installed and ready. Smart contract example. If your contracts compiled migrated successfully, below you will show a stored value of 5 by default. Try changing the value on line 42 of app.js and the stored value is 5. And now we are going to do the same, but we are going to do it from scratch, right? So I will go to simple storage.sol. Inside this, I will go to app.js. Just remove all of these code because we are going to create everything from scratch so that I can explain you each and everything how we are going to code our decentralized application. Now, in order to code your decentralized application, first of all, you are going to need React code. Okay. And for that, we are going to import React. We will require this use state and use effect. I hope you know all of these things. If you do not know, just don't worry, because we are not going to do a lot of React code and all those things. We are just going to see how we can create a simple decentralized application using Web3.js libraries. Okay, so if you do not know what is this use state and use effect, just don't worry. from React. Okay. Then we are going to require the Web3 library, which is actually provided by our truffle only. So I will say get Web3 from get Web3. Okay. So we do not need to install anything. Truffle provided us with this library. Okay, I think I made a mistake here. Let me have a comma. Okay. Now we require one more thing, that is the JSON file for our decentralized application, so that we can connect our React code or we can talk with our smart contract using this ABI of our smart contract. So I will import simple storage from, so it is available in our contracts, right, inside our simple storage.json. Okay, so I'm importing this code inside our app.js, and let us import the app.css so that we can have a good layout. .css. Now we will create our application, right? So we will create our first component, or you can say function. Okay, let me export it also so that we do not forget. Export. Now inside this we are going to use state, or you can say it as web3 if you want, so that you do not get confused. Web3 set web3. Okay, and then you can use state, and we are going to set the state for web3, as well as we are going to have one more thing in our this object, that is null. Okay, we are going to require this web3 as well as this contract, and then we are going to require one more use state for storing the value. Okay, you will understand once we are going to code all of these things. Set storage use state, this will be initially. Now we will have our use effect. Okay, and now we will write some code, guys. Okay, use effect. Now inside this use effect we are going to have one function called init function. Async, you can name this function by anything, right? I'm just naming init because like in our previous like old version of React code that we have seen, right, that was having this init function only, so that's why I'm naming it init. Otherwise you can name it anything that you want. We will have a try block so that if there is any error we are going to catch that error. So first thing we are going to require is web3. Okay, I think we are going to require web3, so let me make it state only. Okay, otherwise it will confuse us. State, let's have set state only. Now inside this we will have our web3. So await, we are going to use this get web3, and now we will have the network ID. Okay, this network ID will help us to have the contract address. Okay, so network ID, we are going to use here web3.eth.net.get ID, and then we will have our const deployed network. So this will help us to get the address of our smart contract, okay, that we are going to deploy to our Ganache blockchain. And inside this we are going to use our simple storage JSON file that we have just imported. Inside this we are going to use network. Now these are the syntaxes, guys, so don't think that I am doing something like these are not something related to the concepts. What I am trying to tell you here is all related to the syntaxes that is available in our web3.js library. Okay, so we are going to have this network ID. Okay, so this is our contract JSON file, then we are using this network ID in order to have this deployed network. Okay, I can console log this thing so that you can see that also. Console.log this deployed network dot address. So this will be our contract address. Now we will create the instance of our smart contract. Instance new web3, we have seen this syntax also, right? Contract. Inside this we will have our ABI, simple storage dot ABI, as well as we will have our deployed network, means deployed network address. Okay, so we will have our deployed network and our deployed network dot address, means the contract address, and then we will set the state once everything is done. Web3 contract equal to instance. So by this we can set the state, and now if there are some error, in that case we are going to catch those error. So let's say if there is some error, we are going to have an alert statement stating that failed to load web3 or contract, and we can console log the error also if there is some error. Console.log there is some error, and now let us call this init function. Okay, let us call this init function. I will explain you, do not worry anything about it. I will explain you each and everything. So it's a very simple structure in which we are actually making sure that we have the JSON format of our smart contract, we have the ABA of our smart contract, we have the, you can see that we have this instance of our smart contract, right? And then we can have the web3, means this web3 that we are going to use in order to communicate with our smart contract. Okay, that's why if you will see, first of all we need this, like we needed this state in order to set this web3, and we have set this web3 using this get web3 function, and then we have set it this contract using this instance by creating this instance of our smart contract. So these are the things that you are going to do each and every time whenever you are going to talk to your smart contract. So these are the things, I will say these are this is something you need to always do, right? Just copy paste these things, just have this thing copy paste it to your notepad or something, just copy paste the same line of code to your VS Code whenever you are creating a decentralized application. Just change this JSON format and everything, otherwise everything else will remain the same. Okay, so this is something, this is just like an outline in order to create, in order to talk to your smart contract. Hi, so in the previous video we have seen how to create the structure in order to talk to our smart contract, right? So we have written a little bit of code in order to create the instance of our smart contract so that we can interact with our smart contract. So now we will make some functions in order to talk to our smart contract. So we are going to create a function, get value function, which will actually help to get the value from this smart contract, this stored data value from this smart contract. So first of all, we are going to create use effect. Okay, and now we will create function called get value. Now in this get value function, first of all we need the instance of our smart contract, so we are going to do a little bit of this destructuring, right? Okay, and now we will have the value of our smart contract, and we have seen this syntax before also, right? Await contract dot methods, and now let us set this value, set storage. Let me do one thing, it is storage value, right? So let me make it set storage value, and now we will use it, set storage value, in order to set the value for smart contract. Okay, so now this function is done. So when we want to call this function, we want to call this function only when we have the state of our state dot contract of our smart contract. So when it is there, then and then only we are going to call this get value function. And when we want this use effect to work, we want this use effect to work when we have the state dot contract. Okay, wonderful. So now let us have the return statement so that we can render some value to our browser. Return statement will have if class name. I'm using the previous value. Inside this we will have the stored value is, and we are storing our value in our this variable, right? Storage value. We will have our storage. This is done. So our decentralized application is completely ready. So when we are going to run this decentralized application, we will see a value that is associated with this stored data. Okay, since we are calling this get function right here, so we are calling this get function. This get function will call this, and this will return us this stored data. Now for change, let me make this 10. Okay, let me make this 10, and now let us redeploy our smart contract, because we are making some changes to our smart contract, right? And since the smart contract is immutable, so we need to redeploy our smart contract so that we can see those changes in effect, right? We will again go back and let me compile our, when we will compile our smart contract, it will provide us with new simple storage.json value, right? This new file, because we have made some changes to our smart contract. So a new ABI and a new bytecode will be generated. Now we will deploy our smart contracts. Okay. 8 dash dash set. Okay, so now everything is ready. In order to run our decentralized application, we will write npm start in our client folder. So this will start our React application. Okay, so our decentralized application has started, and you can see that we have this, the stored value is, but it is asking for our MetaMask transaction. So let me enter my MetaMask password, and here you can see that we have the value stored in our smart contract on our browser. So our decentralized application is completely ready. We are fetching the data from our smart contract to our browser, and let me go back to our code so that I can just give you a quick recap what we have learned. Okay, so first we have created this structure in order to talk to our smart contract, and you have to do this, you have to repeat this structure again and again when you have to talk to your smart contract. Okay, so this is something that you can think of it as a, a magic, or you can think of it as a box that you have to open every time when you are creating your decentralized application. Okay, and it is very easy, right? We are just fetching the web3 library. Okay, then we are using this network ID in order to fetch the address of our smart contract. Okay, and then okay, we haven't console.log this statement, right? But it's okay, I think you might have got this. Okay, let me see that we might our console. Okay, so we have a lot of warnings. Okay, it is saying that at 41.6 we have a missing dependency state. Okay, let us do this. Then we, okay, it is talking about ethereum.enable, but for now we are not going to make those changes because it's something related to future, right? So we do not need to for those things. But one thing, and do not worry about this statement, you are going to see this statement most of the time. I tried to remove it, but it does not go, it does not went away. Don't worry about it. But at 41.6 let's make some change. Okay, at 41.6 is saying that we should have a, now it is saying that okay, there are some issues related to the css, but since we haven't done anything with the css, actually the truffle react box is something very old, so you might have to make some changes to the css one, but we are not going to do that, all those things in this video. But for now you can see that we have this contract address, right, which we have console log while creating our decentralized application, right? And we can see this contract address on our ganache also, our ganache, right? So you can see that we have this created contract address. Okay, and this is our sender address. So the person who is actually doing this thing, this is the person who is actually calling this smart contract, this call function. You might be thinking like we haven't mentioned any address here, right? So when you are not mentioning any address, so by default it is taking like by default this web3.js library is taking account 0 as the by default address. Okay, that's the thing. You are going to mention from address, then definitely you can choose any account from this ganache. If you are not mentioning any addresses, then in that case account 0 will always be the address from which the function will be called, the smart contract function will be called. Okay, so this is something very simple. So this is the contract address instance, and then we have a simple function in order to fetch the value, and we have seen this also, right, in our previous video, like how to call the function from our smart contract, how to interact with our smart contract, and then we simply just render that value on our browser. What is Truffle? Truffle is a tool that helps us to develop, compile, test, and deploy our smart contract on our development environment. Now, what do I mean by on our development environment? Means on our system, we can easily develop, compile, test, and deploy our smart contract. And we are going to see all of these, like how to develop, how to compile, how to test, how to deploy our smart contract using Truffle. Now in this video, what I want you to remember is that Truffle is just a tool. Remember this point, that Truffle is a tool. That's why I've highlighted this point. Now why I am stressing on this point is because as you will progress in this course, you will find some new terminologies like Ganache, some new terms. So I do not want you to confuse at that point of time. So I want you to remember this, that Truffle is just a tool like any other tool. Like we also have Hard Hat, with the help of which we can also develop, compile, and test and deploy our smart contract. So truffle is just a tool. Remember this point. Okay. Now you must be wondering, like, what is the use of truffle? Like, we can do all these things like develop, compile, test, and deploy. Everything can be done with the help of our Remix ID. So why are we using truffle? So let me give you two main reasons of why to use truffle. First reason, easy front-end integration. Suppose in future you want to make a decentralized application. In order to make a decentralized application, you have to integrate your smart contract with some front end, right? And this front end can be in any language, like in React.js, in JavaScript, AngularJS, any programming language, any framework, or any library, right? Now, in order to integrate these two so that you can make a decentralized application, you need something, and that is Truffle. Truffle makes front-end integration very easy in case of decentralized application. So that's the first reason that why we should use Truffle. Second reason, everything at one place. Now, in order to make a decentralized application, you need to code both in JavaScript as well as in Solidity, right? And if you are using Remix ID, so in our Remix ID, we can only write our Solidity code. So in order to make a decentralized application, we have to constantly keep on switching between our Remix ID and the coding editor that we are using to write our JavaScript code or our React.js or AngularJS code. And as a developer, it is a very hectic process, right? We do not want to do that. Now, with the help of Truffle, Truffle provides us with an environment where we can write everything at one place. With the help of Truffle, we can use any code editor to write both our Solidity code plus our JavaScript code to make our decentralized application. So that's the beauty of Truffle. Like, it makes the work of developer very easy. And that's why we use Truffle. Definitely there are various other reasons of using Truffle, but these are the two main reasons of using Truffle. So I hope you like this video. Meet you soon in the next video. Now let us install Truffle, and I assume that you already have installed node.js like from our previous video. So let's install Truffle. So npm install -g and Truffle. Okay, and just press enter, and in some time Truffle will be installed into our system. Out of 5 to 10 minutes, you will see this line, Truffle at the rate of 5.4.24. This line means that Truffle has been successfully installed into your system, and you can check this also using Truffle --version. Simply by typing this, you can see the version of the Truffle that is installed into your system. So here we have our Truffle, that is, okay, we mistaken with Truffle. I think it is Truffle -v. Let's see. Okay, this is also not the right command that I was looking for. So let me write Truffle version, okay, directly. Now let's see. Okay, wonderful. So here you can see that we have Truffle v5.4.24 Solidity version 5, but we are going to change it to 0.8.9. Then we have Node v14. Then we have Web3.js version 5.3. So this shows that our Truffle has been successfully installed into our system.